Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Shahira Akmal binti Hassan for class 13. Today, I will present for my part introduction for liquid role model Weizsacker. Before my members tell the details about liquid role model, let me share a little bit about background of liquid role model Weizsacker. The definition of liquid role model describes force in an atomic nucleus as if the atomic nucleus were formed by nucleons, protons, and neutrons, while the function of liquid role model is used to approximate the mass and various other properties of an atomic nucleus from the number of protons and neutrons.
For the next slide, that is the volume term, we can consider the storm force has a very limited range and the nucleon itself may only interact with its direct neighbors. Consider this analogy that liquids often considered as incompressible as it repels itself if pushed too close. For larger volume nuclei, they should be proportionally more binding energy. For the surface term is based on the storm force. The surface of nucleons interact with fewer nucleons as they are separated from the deeper nucleons. It is also repels itself if pushed too close together as it is incompressible. For the Coulomb term, this term explains the Coulomb repulsion between the distributed protons. The protons are pushing each other, thus the Coulomb force is much lower, yet it still weakens the binding.
Asymmetry term. The equation that shown in the picture is known as the asymmetry term or also known as a Pauli term. The theoretical justification for this term is more complex. The Pauli exclusion principle states that no two identical fermions can occupy exactly the same quantum state in an atom. At a given energy level, there are only finitely many quantum states available for particles. What this means in the nucleus is that as more particles are added, these particles must occupy higher energy level, increasing the total energy of the nucleus and decreasing the binding energy. If we could have some particle from the neutron pool to the proton pool, in other words, change some neutron into proton, we will significantly decrease the energy. The imbalance between the number of proton and neutron causes the energy to be higher than it needs to be for a given number of nucleons. Next, I will explain about pairing term. This term captures the effect of spinning coupling, found empirical to have a value of about 1000 kV, slowly decreasing with mass number of A. The binding energy may be increased by converting one of the odd proton or neutron into a neutron or proton. The pair have overlapping wave function and sit very close together with a bond stronger than any other configuration. When the pairing term is substituted into the binding energy equation for even Zn, the pairing term adds binding energy, and for odd Zn, the pairing term removes binding energy. Due to the Pauli exclusion principle, the nucleus will have a lower energy if the number of protons with spin up were equal to the number of protons with spin down. This is similar effect to the asymmetry terms.
From this video, we can conclude that liquid drop model describe the atomic nuclei by their nucleons behaving like molecules in a drop of liquid. The binding energy can be found by volume terms minus the surface term minus the asymmetric terms minus the Coulomb terms plus the pairing term. The disadvantage of this model is that it does not explain all the properties of the nucleus. The stability of nuclei is not explained by the magic number. This model unable to describe the concept of pairing. That's all. Thank you for watching.